This is Lab 7 at-home video lab report. My name is Olivia again, and the subject of this lab is black hole mass. The objective of this lab is to analyze the effects of a black hole on an orbiting star, as well as determine the mass of the black hole using information given. So, the first thing I had to do was to set up some computations that would give me the mass of a black hole that the star was orbiting. I used the equation for the force of gravity between two objects, and I am measuring the force of the black hole on the star. I set the black hole's position to be at the origin, so the position of the star is a position vector that will be used to compute velocity and momentum, and that will also be used in the force of gravity equation. So, to calculate the mass, I first computed the x and y components of velocity using the star data to find v initial and v final. Using these values, I was able to calculate p initial and f initial by multiplying the respective velocities by the star's mass. By subtracting p final minus p initial, I found delta p, or the change in momentum. Next, I found dp dt to be delta p divided by delta t, the overall time period. Using the momentum principle, I set dp dt equal to F net, which is the total amount of force being exerted on the star. Now, I have all the components that are necessary to find the mass of the black hole: F net, star position, star mass, and the constant g. By switching around the equation for the force of object 1 on object 2, I solved for black hole, and when I ran it and printed the black hole value, I got a value of 1.98 e to the 31st kilograms. The mass had to be very large because the force of gravity on the star by the black hole was very strong. So, next I needed to find the components F net parallel and F net perpendicular to observe the direction of their forces in their relationships with momentum. First, to calculate F net parallel, which is the component of dp dt that is parallel to p hat, I found p hat by dividing p final by the magnitude of p final. I then multiplied this value by the magnitude of dp dt to get dp dt parallel. This value is the same thing as F net parallel, due to the momentum principle. Second, I calculated dp dt perpendicular, which is the component of dp dt that is perpendicular to p hat. I used my value of p hat that I previously found, multiplied that by the magnitude of delta p, and divided by delta t. This gave me the value of dp dt perpendicular, which is equal to F net perpendicular. To visualize these forces, along with F net, I created 3 arrows to represent the forces, which you can see when I run this code. F net points in the same direction as dp dt, because, according to the momentum principle, their values are equivalent. F net parallel points in the same direction as dp dt parallel, because they are equivalent. dp dt parallel points in the same direction as momentum because it moves in the same direction at one point as it does on average. F net perpendicular points in the same direction as dp dt perpendicular, which points perpendicular to momentum because although they have the same magnitude, the direction is different. When I run this code, you can see a red and a blue arrow. The red represents F net, and you cannot see F net parallel because it is the same magnitude and direction as F net. F net perpendicular is blue and perpendicular to the other two. dp dt parallel and dp dt perpendicular are related to F net parallel, and F net perpendicular. dp dt and F net and dp dt parallel and F net parallel, and then dp dt perpendicular and F net perpendicular are equivalent not only in magnitude but in direction as well. The forces are in the same direction. The difference between these values is that although they have the same values, different methods are used to calculate them. The momentum values are found by multiplying velocity times mass, while the forces are measured. So, for the what if question. So what would happen if we did this same problem with a different black hole placed at the same location but with a different mass? Well, because the star is staying in the same orbit, and all the other values are constant and are the same as they were before, there is no way to calculate the mass of the different black hole, because if all values remain the same, then the answer will be the same since we are using an equation to derive the mass of the black hole.